Hey everyone, Sebastian here, doing a special video where I go through all the most important equations you need for the SAT. I'm going to write out the equation and then I'm going to do a question that would use the equation. The questions aren't the most complicated, they're mostly just here to help you see how the equations are used, right? They'll be quick and easy, but I want you to know these equations, and if you know them, you'll be solid. A lot of these are already on the SAT reference sheet, but some of them aren't. Okay, so let's start with area of a circle, a classic. It is equal to pi r squared. And now let's look at the question with it. What is the area of a circle with a radius of 6 pi? So pi r squared, right? The radius is r. So it's just going to be pi r squared equals pi 6 squared equals 36 pi, and pi equals 3.14, and you can solve for that. Most of the SAT you would just leave it in that way, and that's how we'll leave it here. So easy peasy, right? Pi r squared is area of a circle. Let's go on to circumference of a circle. So circumference of a circle is very similar to pi r squared, but it's 2 pi r. So you're doubling the radius and multiplying by pi. So here we have area of a circle. Circle A has an area of 169 pi centimeters squared. What is its circumference? So we can use the first one, right? They often have used multiple equations in the same question. Equals 169 pi. The pi's cancel, so r squared equals 169. You square root both sides, and you get r equals 13. Okay, so if r equals 13, now we can plug that into 2 pi r, and we'll do 2 pi times 13, and that would get us 26 pi, right? So that's an example of what you could do with circumference equation. Okay, now we're going to do perimeter of a rectangle, which is simply 2 parentheses L plus W. So it's the sum of the length and the width times 2, right? Because there's 2 of each. So we have length of 7 and width of 9. We would just do 7 plus 9 times 2. 7 plus 9 is 16 times 2 equals 32, right? So easy peasy for that one. Now we'll go on to area of a rectangle. A lot of these, the earlier ones, right, I think are pretty straightforward, but I'm just doing an example for everyone to see. Okay, so here we have so area of a rectangle, right, is length times width. A rectangle has a perimeter of 18 and a width of 2. What is its area? So we could use the first one again. 2 L plus the width is 2 equals 18. We divide by 2 and we get L plus 2 equals 9, and we get L equals 7. And then to find the area, we would just do 7 times 2, and that would get us 14, right? Easy peasy again, not too bad. Now let's do area of a square, which I think is a fun one. Now area of a square is just sides squared, because all the sides are the same, so it's length times width, when length and width are equal. So area, a square is an area of 256. What is its perimeter? We would do s squared equals 256. S equals 16. Perimeter, right, there's 4 sides, so you just do 4 times 16. I didn't put down perimeter for square because you don't really need it if you know perimeter of a rectangle and also area of a square, so it's going to be 64, okay? So again, we're going to move through these quickly just so you got a feel for them and just so you can see them all building up. So now let's go on to the next one. Area of a triangle is similar to area of a rectangle, right, but it's half of it, so it's going to be 1/2, and they usually call it base times height. So for this, we have a base of 6 and a height of 10. What is its area? We would do 1/2 6 times 10. This math is pretty easy, so you could just do it in any order, but normally I divide first and then multiply. So it'd be 3 times 10, and that is 30, okay? And that is area of a triangle for you. And now we're going to go on to Pythagorean theorem, and I think this is the beginning of actually more complicated equations. A right triangle has a side length of 12 and a hypotenuse of 13. What is its area? So it's a right triangle, and with right triangles, Pythagorean theorem tells us that one side squared, one leg squared plus the other leg squared equals the hypotenuse squared. A squared plus b squared equals c squared. So we have a right triangle with a side length of 12 and a hypotenuse of 13. So it's going to be 12 squared plus b squared equals 13 squared. We're going to get 144. Plus b squared equals 169. B squared is going to be, when you subtract, 25, so b equals 5. And then to find the area of that, you would do 1/2 base times height, right? Because it's a right triangle, the two sides are going to be the base and the height. If they weren't right angles, you'd have to do other math to find it. It would be like this, because it's sort of like, you know, imagine it, 12, 5, 13. 12 times a half is 6, so we have 6 times 5, which is, again, 30, okay? So now we're going to be doing some more right triangle stuff before we get into volume, and we're making good progress here. I'm happy with this. A lot of this is geometry. A lot of formulas are involved in geometry, but they're not too bad at all. Okay, so a 30, 60, 90 triangle is a special right triangle. This and 45, 45, 90 are two special right triangles. This is one angle's 30, one angle's 60, another one's a 90. And the ratio across from 30 is x, across from 60 is x times root 3, and across from 90 is 2x. So for this, I'm just going to write x colon x root 3 colon 2x to remember the ratios. An equilateral triangle has side lengths of 6. What is its area? That doesn't seem like a 30, 60, 90, but you can see how you apply it here. Look. So this angles are 60, right? In a equilateral triangle, we draw the altitude down to find the area, to find the height, right? So this is 60, and this just got split in half. We now have a 30, 60, 90. This is 6, so if that's the hypotenuse of 6, that's 2x. So x would be 3, and this would be 3 root 3. So here we have an isosceles right triangle has an area of 18. What is its perimeter? So an isosceles right triangle, right, we have a 45, 45, 90, because that isosceles means two sides are the same, so that means the legs are the same here. And that gives us x, x, x root 2. So it would be x colon x colon x root 2. So they're the same, so it's going to be 18 equals 1/2 base times height, but here they're the same, so it equals 1/2 x squared. So 36 equals x squared. So x equals 6. So the perimeter would be double that, because there's two of them, plus 6 root 2 for the hypotenuse. So that'd be 12 plus 6 root 2. And again, you can see how you can blend different equations and start using them together to find various aspects. And with volume of rectangular prism, it's nice and easy. It is length times width, so it's like the area of a rectangle, times height. So here, width is 8, height is 6, and a length of 11. So we just do 8 times 6 times 11, which is 48 times 11, which is 528, right? Nice and clean and beautiful. I love this equation, and it helps us understand the future equations, right? It's always area of a base times the height if you're going straight up, and if you're going to a point, you do it by a third. Here we have a cylindrical bottle is 3/4 full of water. The bottle has a height of 10 centimeters and a radius of 2 centimeters. How much empty space is in the bottle? So volume of a cylinder is going to be the area of the base, which is the area of a circle, which is pi r squared, times height. So now we're sort of combining area of a circle with volume of a prism, right? And this is going to give us height of 10, radius of 2. So it's going to be 2 squared pi times 10. So we're going to get 4 times 10, 40 pi. Now that's the full bottle, and it's 3/4 full. So times 3/4 to find out how much full it is, and that will give us 30 pi. And then how much empty space is there? We would do 40 pi minus 30 pi. And we can do that because they're like terms, and we're going to get 10 pi. Okay, so you can see how the equations are stacking together. You know, that's how usually the SAT works, is where you stack equations together to find answers. But you need to know the equations before you can really stack the equation. And now we have a sphere has a radius of 4. What is its volume? So volume of sphere is 4/3 pi r cubed. So if it's 4, we'll do 4 cubed, 4/3 times pi. 4 cubed is going to be 64 times 4 is going to be 256 pi over 3. And that would be our answer for this one. Again, Not a terrible question by any means, but they can obviously get more complicated than that. And for a cone, it's like a cylinder, except it's 1/3. So it's going to be pi r squared h over 3. So with pi r squared h over 3, we're going to do, a cone has a height that is twice the radius and a volume of 18 pi. What is the sum of the height and radius? So we're going to have pi h equals 2r, right? So we're going to have pi r squared times 2r over 3 equals 18 pi. So that's going to give us 54 pi. So we have 2r cubed. Pi equals 54 pi. Divide by 2r cubed. Pi equals 27 pi. Cube root divided by pi r cubed equals 27. And cube root at r equals 3. So then h has to be 6. And r plus h has to equal 9. Okay? So you need to know this equation, right? Pi r squared h over 3. Okay, so now we have volume of a pyramid. It's the same thing except there's no pi. And instead of r, it's going to be 1/3 LWH. Okay? So for that one, we have this equation here. Pyramid with a square base has a height equal to edge length of the base. What is the height if the volume is 72? So here it's a square base, so instead of LW, we'll do S squared. And since the height is equal to it, it'll be S cubed. So we're going to do 1/3 S squared times S equals 72. Multiply by 3, we get S cubed, right? Anyway, equals 216. S equals 6. That is the height. And S equals H equals 6. Okay, so straightforward again. Now we're going to go into another one that is maybe the most confusing for my students, but also one of the most important ones. So let's try it out. So when we're dealing with formula of a circle, it's something like this. It is written as x minus h squared plus y minus k squared equals r squared, where h, k equals center and r equals radius. So it's going to be x minus h squared plus y minus k squared equals r squared. They're getting longer here, but they're still not too bad. So if the center is 4, 5, and the diameter 14, diameter is twice radius, so it would be r equals 7. 4, 5, so we would do x minus 4 squared plus y minus 5 squared equals 7 squared, which is 49. Okay, one counterintuitive thing is you subtract the center, you don't just add it. So it's not x plus 4, y plus 5, it's x minus 4, y minus 5, and you square them. All right, so now we're doing a quadratic equation, right, which if you don't know is going to be negative b plus or minus square root of b squared minus 4ac all over 2a. This is used to find the solutions in quadratic equations, right? 3x squared plus 5x plus 1 is an example. So what are the solutions? The 3 is the a, 5 is b, 1 is c, right? It's always the number that x squared is multiplied by is a. So we're going to do negative b, we'll do negative 5 plus or minus b squared, 25 minus 4, a is 3, c is 1, all over 2a, which is going to be 2 times 3. And that will give us negative 5 plus or minus root 13 all over 6. And the two solutions, right, would be negative 5 plus root 13 divided by 6 and negative 5 minus root 13 divided by 6. That equation's too big to really fit here, right? There's a lot of equations that had to fit in here. So I'm just going to draw an arrow for it. And we'll go on to the next one. What is the minimum for a function f of x equals 3 parentheses x minus 5 squared minus 2? So this is for vertex form of a quadratic. So like formula for a circle, it's like you're finding the center. Here you're finding the vertex, and it is y equals a x minus h squared plus k, where h and k is the vertex, right? So y equals a x minus h squared plus k, where h and k equals vertex. And vertex is the maximum or the minimum. Here it's a minimum because it's curling up because a is positive. So here the vertex would be at, this is the x value 5, comma negative 2. So the minimum is negative 2. If I was asking for the coordinate, it would be 5, comma negative 2. Okay, so this is a very useful equation, just like the quadratic. You're asked for different parts of it to answer questions on the test, and I think a lot of times they're some of the hardest questions you'll find. Not exactly this level. This one's more going over the basics. Now we have how many degrees are in a pentagon. So degrees are always going to be 180 times number of sides minus 2 in parentheses, right? So we're going to have 180 times 5 minus 2. So it's going to be 180 times 3, which gets us 540. If you wanted to find the number of degrees per side, you would divide that by the number of sides. So you do 540 divided by 5, and that will get you 108. So this is just going to be 180 and minus 2. Nice and easy, right? Nice and clean. I love it when it's like that. Now, point-slope form is a very useful equation that's often underused in schools, but the SAT does want you to use it. And point-slope form is like this. It's going to be y minus y1 equals m, which is slope, parentheses x minus x1. So x1 and y1 are our points. So if you have a perpendicular to a line with a slope of negative 2, if it's perpendicular lines are negative reciprocals, so the slope is going to equal here, m is going to equal 1/2, and then the point is 4, negative 6. So we're going to do y minus negative 6 equals 1/2 x minus 4, and we can combine the left side, so it'll be y plus 6 equals 1/2 x minus 4. And you would move it over to find point slope-intercept form, but it's not asking for that. It's just asking for the equation, so you can leave it like this, and that is point-slope form. So now we'll try another one that has slope-intercept form. So in slope-intercept form, right, we're going to have y equals mx plus b, where b is the slope, or where m is still the slope, y and x stay, and then b is the y-intercept. So here, same thing with a slope of negative 2, perpendicular with a slope of negative 2, and crosses the point 4, negative 6. So we already have it written, so we would just move things over and get y equals 1/2 x is going to be 1/2 x. 1/2 times negative 4 is negative 2 minus 6. And we get y equals 1/2 x minus 8. And this is the y-intercept. Okay, so I think this is all coming together. We have 2 left, and then we'll be done. And you'll be able to see all the equations that I think are really crucial for the SAT. And again, if you ever have questions on any of these, I'm more than happy to help with them. So here we have distance formula. Distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. So it's the 2 points, they're distant from each other, and then you square them each, and then you square root it. So for here, to find the area of a circle, right, we're going to have to do the distance from the center to the edge. So we'll do, I'm going to write this here first. It is going to be, and it doesn't matter which order you put them in here, because the square is going to make them positive anyway. So you'll do 3 minus 11 squared plus 5 minus negative 1 squared. So that would be 3 minus 11 is negative 8 squared plus 6 squared. And that would be 64 plus 36. And that's 100. And you square root that, and you'll get 10. So that's the distance from center to edge. So that's the radius. And then to find the area, right, we would use the first equation, pi r squared. So we would get 10 squared times pi, and we've got 100 pi units squared, or square units. Okay, and now we have our last one, a classic slope formula. I think a lot of people learned that in 7th grade in the US. And it's definitely one you want to know. It's definitely helpful, and it's not too bad. I think really the hardest ones to really nail down are vertex form of parabola, formula for a circle, and probably quadratic equation. So for slope, it is just going to be x1 minus x2 over y1 minus y2. So it's going to be x1 minus x2 over y1 minus y2. So here we're going to do 4 minus -1 all over 7. You want to make sure they align, right? So this is the x1 we're saying, so this has to be y1. 7 minus 12. And that gives us 5 over -5, and we get -1 as our slope. Down, you're going down 1 on y every time you're going 1 over on x. So if you have questions on this one or any of the equations, let me know. You have the full list here, and I can always type them up for you in the comments if you need them. But here they are. I think if you know all these, you're in a really good place to start on the SAT, and from there it's just about combining, reading carefully, and understanding how to think logically about the questions when they ask them. All right, so I hope this helped. Ask any questions like always, and I hope it's sunny where you are, and if it's raining, I hope it's cleaning your windows and watering your plants. Bye.